Hello and welcome to yet another Korean College Scholastic Ability Test video. This problem is from the most recent exam, 2023, which was held only several days ago. The test is named with year 2023 because it is for the students who will start their college year in 2023. And this problem is very similar to this particular problem from the last year's exam, where you have to calculate the complicated limit after doing some decent amount of geometry. You can check the link in the description or at the top right corner of this video. And as you see, they've come up with very similar problem also in this year, so I am going to solve this one for you as well. First of all, reading everything written in here is really a tedious job, so I will just explain the problem visually with the animation. So there exists a semicircle with center O and diameter AB equals 2, and on that semicircle exists point C such that angle AOC is right angle. Take points P and Q on arc BC and arc CA respectively, such that the length of PB equals the length of QC, and take point R on line segment AP such that angle CQR is also right angle. Let S be the intersection point between line segments AB and CO. When angle PAB equals theta, let F theta be the area of the triangle POB, and let G theta be the area of quadrilateral CQRS. What is the value of the limit of 3F theta minus 2G theta over theta squared as theta approaches 0 from the right? And this is actually a multiple choice question. And here, theta is in between 0 and pi over 4, because this figure has to make sense. Just like my video on the last year's limit problem, the problem solving steps are pretty straightforward. We just have to find the expressions for f theta and g theta. Then we can find the expression for this. Then we can let theta approach 0 and find out the value of the limit. So let's get right onto it. Alright, first, the area f theta. This one is pretty easy. First, length of OB and OP are both 1, which is the radius of the given circle. Next, note that this theta is an inscribed angle for arc PB. The center angle for the same arc is this angle POB, and by the inscribed angle theorem, that center angle is simply twice of the inscribed angle, so this angle POB equals 2 theta. You can also find this from the fact that triangle OAP is isosceles, and thus this angle is theta, and angle POB is an exterior angle of triangle OAP, so it is the sum of this angle and this angle. Therefore, the area f theta can be calculated using 2 side length and the angle between them. So we have 1/2 times 1 times 1 times sine 2 theta, which is 1/2 sine 2 theta. And you can always use double angle formula for sine to write this as sine theta cosine theta. Okay, that was easy. Now let's move on to g theta. Alright, now the area g theta. First, let us find out what kind of quadrilateral this is. We know that this angle is theta, and this angle is 2 theta, and angle APB is right angle because AB is the diameter of the circle. So we have this angle as pi over 2 minus theta, and this angle is also pi over 2 minus theta. Therefore, if we connect point O and Q, we know that triangles POB and QOC are congruent, so this angle QCO is also pi over 2 minus theta. Also, this angle ASC is an exterior angle of triangle AOS, so it is simply the sum of this angle and this right angle. So this angle is pi over 2 plus theta. Therefore, we have this angle plus this angle equals pi, which means that line QC and AP are parallel. This means that quadrilateral CQRS is actually a trapezoid. Therefore, area g theta can be calculated as 1/2 times QC plus RS, the sum of two bases, times the height QR. So we need to find out length QC, RS, and QR. First, it is given in the problem that this length QC is equal to PB, and we have angle APB equals right angle because AB is the diameter of the circle. Hence, QC equals PB equals length of AB times sine theta, which is 2 sine theta. The next thing we have to do is to put down a foot of perpendicular T onto line segment QC from S. Then we have this angle as pi over 2 minus theta, and this angle is right angle, so this angle is theta. So we know that length QR is equal to length TS, which is again CS cosine theta, and length RS is equal to length QT, which is QC minus TC, which is QC minus CS sine theta. We already know the length of QC, so we have to find the length of CS. Here, CS equals OC minus OS, and the length of OC is simply 1, which is the radius of the circle, minus OS equals OA tangent theta, and this length OA is also 1, so the length of OS is simply tangent theta. So we have 1 minus tangent theta. Therefore, from here, QR equals 1 minus tangent theta times cosine theta. So we have cosine theta minus cosine theta tangent theta, and this cosine theta tangent theta equals sine theta. So we have cosine theta minus sine theta. And RS equals this QC equals 2 sine theta, and we have minus 1 minus tangent theta sine theta. So we have sine theta plus sine theta tangent theta. Here, let's leave this tangent theta for now. So finally, with these obtained length, g theta equals 1/2, and we have QC, which is 2 sine theta, plus we have RS, which is sine theta plus sine theta tangent theta, times we have QR, which is cosine theta minus sine theta. So we have 1/2. This part becomes 3 sine theta, and we have the rest. And we can take this sine theta to the front, so we have 1/2 sine theta, 3 plus tangent theta, cosine theta minus sine theta. And this is the expression for g theta. Alright, so now we have obtained both f theta and g theta, and we have to find the value of this limit. So first, let us simplify this expression. First, we have 3f theta, so we have 3 sine theta cosine theta, and we have minus 2g theta, so we simply have sine theta, 3 plus tangent theta, cosine theta minus sine theta, over theta squared. Now we have to expand this, and let us multiply these two terms first. So first we have 3 cosine theta, then minus 3 sine theta, then plus cosine theta tangent theta, minus sine theta tangent theta. And now we multiply this sine theta using distributive law, but first notice that this cosine theta tangent theta equals sine theta. So first we have minus 3 sine theta cosine theta, then plus 3 sine square theta, then we multiply with this sine theta, so we have minus sine square theta, and finally plus sine square theta tangent theta. So 3 sine theta cosine theta cancel out, and we have 2 sine square theta plus sine square theta tangent theta over theta squared, which can be also written as sine theta over theta squared at the front times 2 plus tangent theta. Now, why pulling out this sine theta over theta? Well, because we have to find the value of the limit of this expression as theta approaches 0, and we have to use this very famous and important limit regarding the trigonometric function, limit of sine theta over theta as theta approaches 0 equals 1. So using our previously obtained result, we have the limit. Here, this sine theta over theta approaches 1, and this tangent theta approaches 0. So we have 1 squared times 2 plus 0, which is 2. And if we take a look at our multiple choices, we know that the correct answer is 2. So this was another challenging geometry plus trigonometry plus limit calculation problem. Personally, I think that the last year's problem was much more difficult, especially in terms of limit calculation. So if you haven't watched that video, please check the link in the description or at the top right corner of this video. Also, if you enjoyed this video, please press that like button and also subscribe for many more challenging and interesting math problems. Thank you for watching, and I will see you in another video.